Hello, I'm Earl Taylor, Chief Marketing Officer at the Marketing Science Institute. As many of you know, nonprofit MSI serves as the bridge between marketing theory and business practice, and our goal is to move the needle of significant marketing problems. We do this by funding research by leading academics worldwide on topics voted by our corporate sponsors and disseminating that research through members-only events and a variety of publications. I'm very pleased to welcome you to another MSI For Members by Members webinar. This is a series of webinars on subjects related to MSI's current research priority topics. First, I'd like to point out the chat with presenter function in the left-hand corner of your screen. Please use this feature to send through any questions you have for Ross during the presentation. We'll gather the questions and have a brief Q&A session following the presentation. Now, I'd like to introduce you to today's featured speaker. Ross Link is the former president of Global Marketing ROI Solutions at Nielsen, and his talk, Marketing ROI Analytics in 2016, The Baby in the Bathwater, was voted one of our most highly regarded presentations for the entire year, and so we're very pleased to present this as a Best of MSI webinar. Ross's former position at Nielsen was global lead for marketing mix modeling practice and multi-touchpoint attribution practice. Prior to joining Nielsen, he was CEO of Marketing Analytics, which he founded in 1991 and ran until it was acquired by Nielsen in 2011. And Marketing Analytics helped pioneer the marketing mix modeling industry, introducing in 1992 the first automated marketing mix model engine, coefficient generator, and in 1995 the first industry usage of Bayesian marketing mix models. So he brings a wealth of experience. Prior to that, he was a consultant at Booz Allen and for 4 years at Procter & Gamble in their corporate analytics group. So with that, we'd like to welcome Ross Link to our webinar series. Ross?
Thanks a lot, Earl. So thanks everybody for joining. I see some names that I remember, and it's good to see you guys there. And thanks, Earl and MSI, for inviting me. And also, I need to thank Nielsen for letting me speak about this. I'm on sort of a sabbatical now between gigs. I've taken a year off and doing some personal stuff and building a house in Hawaii and stuff like that. But we'll be coming back to this. But I do thank Nielsen for being kind enough to let me present this here and a couple other places as well. So this presentation is called Marketing ROI Analytics in 2016, The Baby in the Bathwater. And the reason for that subtitle is that as analytics moves to really granular data, individual level data instead of markets and store level data that we've been using in marketing mix for a couple decades, the analytics need to change, and that's great, and they do need to change. But some of it, some modelers I think they kind of threw out all the other stuff that we've been researching. In MSI has published all kinds of things about this, and in academia and us in the industry as well have done a lot of research and discovered things that really don't need to be thrown out. So that's the point of this, is that yes, lots of things need to change, but not everything. There are some good things that people need to remember when they're doing these kinds of models. So let's see, I know exactly what I'm doing here. So we know that we all know that media spend is following the eyeballs, and it's moving to digital, and particularly mobile. So this is clear. There's several market research companies that have been predicting when the spend on this is spend on media, when the spend on TV on digital will surpass TV, and it should be this year or next year, according to most market researchers. As you see here, it's not a surprise that money's moving to digital, but do notice that it's really moving to mobile. So like digital desktop is kind of, at least, last I picked up data for this about a year ago, was pretty much flat, and it's really mobile that's really growing and taking money away from digital. That's really what's happening. As media buying is dramatically changing along with it. So as we moved, there was a time when I'm probably older. I'm quite sure I am older than most of the people on the phone. But we used to target media based really on age and gender, and I worked on an optimization program at P&G that was really just targeting 4 age groups and 2 genders. That's how many genders we had at that time. But now it's going past age and gender, and we're targeting income, ethnicity, heavy category buyers. And these are something that Nielsen Catalina Solutions, that's a joint venture between Nielsen and Catalina Marketing that uses frequent shopper data from Catalina along with data from Nielsen to do various types of analytics and so on. But NCS has been giving guarantees based on heavy category buyers. I won't give you this many women 18 to 49. I'll give you this many heavy detergent, laundry detergent buyers, and I guarantee it. If I don't give it to you, I'll give you money back, or I'll give you a make good or something like that. So that's happening now. And then we're targeting people actively shopping for a product, and that is a way better way to target than just targeting women 18 to 49 or even women 18 to 49 in a particular city. Much more accurate and brings a lot better data and some issues as well. At the same time, media buying is becoming much more automated as well, because when you were just targeting 50 or 60 major metro markets, a person could have a spreadsheet and say, okay, we're going to heavy up in St. Louis, we're going to lighten up here, and we're going to do more of this particular type of TV in here. And you can do that in a spreadsheet or in a PowerPoint presentation that you send to your media buyer. But you cannot do that when you're targeting 100 million households or 300 million people. Now you've got, or billions of people, when you're doing it globally. Now you really have to do things in an automated way. So programmatic buying in display ads is grown a ton, and it's growing out everywhere in digital, and it will eventually grow into television and other media as well. So we're doing automated media buying. So media buying is definitely changing a lot. So as data moves from broadcast to narrowcast, media measurement requires big data. This is why we have big data in marketing. It's not just suddenly that it's a cool thing to do. It's that there's actually some dynamics here. So we used to target when we had just linear TV, radio, and print, just broadcast media. Then all we really needed was national data, market level data. That's the only way we could target. So that's the way you would see variation in the data. That's the kind of data you could analyze, and that was relatively, I would call that little data. But even in the last 20 years, we've had in-store merchandising, and that is data that you really need at the store level. And yes, when I was at Nielsen, we advocated using store-level data. Even before I went to Nielsen, we were at Marketing Analytics. We did concede that for things that are targeted at the store level, you need to have either store-level data or store group data. And we had a fancy pants way of breaking data up into store groups. But for in-store merchandising, where the variation is at the store level, you need either store data or groups of stores that are all doing the same things. Now, of course, this has been true for direct mail for many years, but now we have all this new types of media, digital, social, mobile, and addressable TV, and now you're targeting things at the household level and the individual level, and at this level, you really need, when you're targeting it that way, you need to look at data at that level so you can see variation in the data. It's basically that simple. You got to see people that saw the ad and people that didn't see the ad, and when you're targeting it this finely, you need individual level to do that, individual level data to do that. So that's how we get to big data. More targeted media means more granular data. Here's a diagram of how multi-touch attribution models use person-level data to assign value to media touchpoints. So here is this is individuals, looking over there, the little people icons on the left there, and we're watching a particular person or household be exposed to a television ad and a digital display ad, some sort of social media exposure in a news feed or something, and then they go to a brand website, and then this particular person made an online purchase of $88. And then what we do is we track each individual person like that, watch everything that they saw at the individual level to the extent that we can. And we can't always, but that's changing. It's going to become more and more possible. And then we watch everything that they bought, either online or at a physical store. And then we run a regression model, a logit model. It can be various things, but either a logit regression or some sort of matched panel analysis, or some even fancier types of feedback models that look at probability of exposure and probability of purchase. But in any case, we're running some kind of analytics. And most commonly really is quite analogous to the marketing mix. It's a logit model, predicting sales using media exposure and the observations at the individual level. Now what we do is we take all the total sales and based on the logit model, whatever type of model we're running, we attribute all those sales to all the different drivers. And so therefore we add it all up. The model's done at the individual level. We get contributions at the individual level, how much of this sales for this individual was due to TV and so on, add it all up, and then we get the the attribution value for each media. So for television, in this made-up example, we figured that $30 of the total sales of all these people came from television, $60 came from display ad, and so on. It's not going to add up to be the total sales because some of it is base sales that would have occurred without any exposure. In the world of attribution, they call that stuff at the bottom fractional attribution values. In the world of marketing mix, we call that decomps, or when you take a difference from year to year, we call that due-tos. So very much due-tos, decomps, same thing as fractional attribution in the attribution modeling world. So that's how it works in attribution models. And when I was at Nielsen and running, in charge of marketing mix models, I got a call from people from another part of Nielsen who said that they were running these attribution models with a partner that Nielsen partnered with at that time. And we, at Nielsen, we use several attribution modeling partners. We're doing it. Nielsen's doing it in-house now, but they partnered with several attribution modeling companies. This is one of the first ones that they were partnering with there at Nielsen, and this was the data that came back. And when I got a call saying, "Hey, Russ, your marketing mix models, I think you probably need to take a look at them because we have this much better attribution, individual level data, and we're getting numbers that are considerably different from yours." And this is real data. It's for a company that we have been marketing. Nielsen's been doing marketing mix models for I think about a decade at least. These are two different brands, but what you see here in the top right there is here's a particular brand, and the attribution model said that about 21% of the total sales for that brand came from television. The mix model that we have been running for, like I say, a decade or so, and getting relatively consistent results from year to year, said 5.5%. For digital display, the attribution model said 12.4% of sales came from digital display. The mix model said 0.5%. So we got definitely a problem there. Same for other brands, so I was charged with looking at this with me being nervous as well, to be honest, because you always wonder what happens when you get more granular data. Are you doing this stuff right? So we dug into the attribution model from this vendor that we were working with at that time, and worked with their technical people. They explained to us how the model worked, and this is how it works, and this is how virtually all attribution models were working at this time in 2013, 14, probably 15 even too, though things have started to change over time in the last couple of years, partially because of what we did, but partially because of many other things in the world as well. But this is how the algorithm worked, as they explained it to me. Number one, assume that any purchase by an individual subsequent to any media exposure is incremental due to media. So basically, if you go back on that previous page, I won't flip back, but you remember the thing with the people and their exposure. Look at each person, and then up until they're exposed to any media, well, I think the assumption is that it is not incremental to the media. It better be. But after each person was exposed to any media, the model builds in an assumption from then on for the rest of the data set that you analyze. All purchases from that person are incremental due to media, and the only job of the logic model is to figure out which media gets the credit. That's the way that worked. Then another one was in the model that we were looking at there to try and compare to our own results, was that they were using fused or modeled TV data. And by that, what I mean is data fusion is what I mean. And there's many ways to do that, but in this particular case, there was the team that was doing this was using Nielsen's TV panel data, and then which is maybe 50,000 people, maybe 20,000 households, 50,000 people, and then for each of those people finding 1,000 or a few thousand other people that were very similar to this person in some way, based on what maybe television shows they watch or some kind of attribute, and then what would happen is that this vendor would assign all of that TV data, every single exposure, every show that person watched in our panel. We would assume 1,000 or 2,000 other people who were sort of similar to that person did exactly the same thing, saw exactly the same TV shows, same commercials, same order, same everything. Okay, it's a kind of a big assumption, but that's one of the common ways of doing fusion. The other issue that the other way that the algorithm was described to us is that there was no saturation concept. It was just linear returns, and then no ad stock concept. So basically, there's sort of a window that this model would look at of about, I think it was about 3 months. So any exposure in that 3 months was given the same credit in terms of figuring out the probability of it influencing a person, whether it happened a day ago or 3 months ago. But if it happened 3 months and a day ago, it gets 0 credit. So a very, very simple kind of a way of using time, the time of when exposure happened. Due to step 1, this algorithm grossly overestimated incremental sales in our judgment and in all of our tests too, by 3 to 20 times what it should be. And that's, I think most of us on the phone here, we have had exposure to marketing mix and we're familiar with the kind of results. And we get, depending on the brand and the industry, anywhere from 5% to maybe 20%, sometimes 30% of sales might be incremental due to media. But a typical number might be 10%. It might be a median somewhere around there. So if 10% of your sales are incremental due to media, in truth, if you assume 100% of them are incremental due to media, you're going to get 10x lifts. Lifts are going to be off by 1,000% too high. And that is basically the problem. That was the biggest problem with this model. It's a huge problem. It does make the ROIs, not just the lifts, it makes the ROIs about 10 times as high as they should be. This is part of, by the way, this is part of why attribution modeling was super popular when it first came out. And it's still pretty popular with media companies because it makes all the ROIs look about 10 times as high as they should be. And with anybody who wants to advocate for lots of advertising, it's a very popular thing. How could this happen? I was thinking when I was first exposed to what attribution modeling was, it just seemed to me, well, this is marketing mix modeling, but with individual level data, which it is. But I really expected in e-commerce, in this type of model, I thought with such great data, they had really great analytics, but it's not true. Maybe because the data is so big, whatever reason. But e-commerce companies, the most common way of doing a due-to analysis, like we do in marketing mix, or decomposition, is basically assume, most common one is last touch. Whatever the person did last, assume all the sales came from that. So if the last thing the person did was they went to your website, they may have been driven there by a TV ad, plus a magazine ad, plus a digital display ad or something, and maybe the display ad had quite a bit of influence at the end. But however it was that they got there, if the last thing they did was went to your website and then were looking there, and then and you don't really know how they went there other than, you don't really care how they went there, they just went there and saw something and learned about your product that way and then bought there, it might all be attributed to that. If they saw a digital display ad and then clicked on it and then did a purchase that way, well, it was a digital display ad, so that's the thing that gets all the credit. Whatever they did last gets all the credit. Other ways, and that is the most common way still today in e-commerce for assigning quote-unquote fractional attribution. Other ways are just, well, let's assume everything that we're doing, we get equal credit across everything, so I'll just assign all my due-tos or decomps equally across all media. Another one is ad hoc. Maybe the CMO might just decree, look, I know for a fact that most of our incremental sales are coming from either our display ads or a brand website, so you have some sort of percentage that's applied to everything. And this slide, by the way, was derived from something that I saw from one of the attribution modeling companies, who I have respect for. I think they know what they're doing. But they called it advanced attribution. This attribution modeling company, are finally doing something that's really new in this industry, and we're doing this sort of advanced thing. What it was is a regression model. So they were calling just a logit model is advanced attribution. Instead of any of all these simple things, we're going to actually do a model of it and figure out where the sales came from. Well, that's the same thing that we've been doing in marketing mix for a couple decades. So they were behind in our analytics, but better data. Let's admit that. Or becoming much better data over time. So what we did was, after understanding how this thing works, we said, look, let's take exactly that same. This is before we started a big research project. Just me and my team said, look, okay, give us this. Please give us that from that attribution modeling vendor. Please give us exactly the data that you just ran that came up with a 21% of brand A sales are due to television. Just give us that data, and we're going to run another model on it. It's all, again, this was individual level data. We ran a model which, number one, no initial assumption about which purchases are incremental. And the model will figure out what's incremental and what's base. Number one, we ran a Bayesian logit model to determine which ones are incremental and which media gets a credit. We used TV GRPs, not modeled data. So, ideally, we would be using set-top box data at the individual level, but we had so little of it. That's why this vendor had resorted to using this fusion type thing. But we didn't feel like that was working very well, and we tried both of them. But we said, what seemed to work better is actually just go back to the old data, use TV GRPs for that market, and then break that down into a probability of exposure. So if we have 20 GRPs in this market, we assigned like a 0.2 exposures to every single person that was in that market. Not ideal, but we actually worked better than that fusion thing. And then we include saturation ad stock, and here's what we got. We got numbers that are way, way, way closer. So where's that brand at 21% of sales were due to TV in the original attribution model, and we got 5.5% from a marketing mix model, we got about 5% when we ran this new spec. So that farthest right thing is sort of the quick and dirty improved attribution model with what we knew really you should be doing in this kind of model. It helped a lot. You'll notice the time periods are different a little bit, but that didn't really matter. Especially you can tell that at first we were wanting, it was possible that because the MTA model had only 11 weeks of data, that was why it differed from the 104 weeks. I mean, it's possible, unlikely. But then when we ran the exact same data, same 11 weeks, we got numbers that were much, much closer. So no, the time period was not it. Do notice this thing though, is that yes, we fixed the bulk of the problem, but if you take a look at, say, on the top right, that digital display for brand A, okay, so they thought it was 12.4. We brought it all the way down to 1.4 with the improved model, but that is still, 3 times as high as what the mixed model is saying. So that's still a 200% difference, and that's still not good enough. So we had fixed a lot of it, but there's definitely more to fix. You can't have 200% potential errors in your ROIs. Clients won't like that. So here's something about this big data in the marketing world is that, we start to put together, and back then there was a real lot of hype back in 2013, 14 about how great all this data is, how it's going to change everything, how marketing mix is garbage. And when you go look at it, you realize, well, yeah, you got some of this data is just awesome, and some of it is not so awesome. So like in U.S. fast-moving, CPG, fast-moving consumer products, single source data availability by person in millions, in the U.S., where we have some of the best data, the most promising stuff for attribution-type modeling, we'll have paid search, email, digital display, website visits. We'll have that for every single person in the country, as long as it was tagged correctly. And by the way, that is a non-trivial assumption. Okay, there's all kinds of problems there, and as long as onboarding happened correctly, and there's another number of things that have to happen. But theoretically, we should be set up to get accurate data for every single person in the country for these things. For sales. In CPG, we have data. All these things are changing, by the way, over time. Probably the television bar is probably the one that's changing the fastest in this. But everything is changing. But the gist of what I have here is still basically true. It's still true. Not basically true. It is still true that these kind of sort of like huge differences in the amount of data we have. Sales data we might have for 60 million, 70 million households, maybe 200 million people, something like that. Television data for Nielsen back at this time and for a number of other companies came from a few different cable set-top box companies that would release their data, maybe Fourth Wall, Charter, a couple like that. And we had about maybe 7.5 million people worth of television data. Okay, that's great. 7.5 million is very good. It's not 320 million. Radio, we had about 70,000 people from our these meters, these personal people meters that people would wear through Arbitron. That's only about 70,000 people. And then in-store display, we don't have that, for anybody really for sure to know that person saw that display. Outdoor, same kind of thing. Again, things are changing over time. Radio will probably get nice streaming data at some point. But at this time, which wasn't that long ago, maybe a year and a half, 2 years ago, about a year and a half ago, it looked pretty much like this. Okay? So that means the number of individuals for which we have searched, all the data that we need to do a nice, clean Loja model, search, email, digital display, website visits, TV, radio, in-store display, outdoor and sales, it's zero. We have all that data for 0 people. Okay? So we definitely have a missing data issue. Another big issue we've got, and this is, I would say, the biggest issue. Like the things that it's the biggest issue now. I think probably not having base sales in these attribution models was probably the biggest issue that threw things off by a factor of 10. As I said. But as these sort of really kind of rudimentary issues get worked out, we get to the more challenging ones, and this is a big one. This is targeting bias, selection bias, people alternatively refer to it as. This is where basically as targeting gets better and better, you're going to get data along a diagonal. It's the top left and the bottom right of this thing. If once the targeting and all the data is really, really good, you're only going to expose people to a paid search ad who are likely to buy that product. You'll expose them, and then the people that are not likely to buy, you won't expose any of them. Okay, and that's actually happening a lot now. That's largely how this matrix will look like for paid search. For not exposed, that top right cell, it's going to go down, but right now there are a lot of people that are likely to buy that don't get exposed. So the design matrix isn't totally messed up, but it's moving toward that. So all of us know from regression, you need to have some sort of balance so that you can separate out the different things. You need to see people that are likely to buy exposed and not exposed, and people that are not likely to buy exposed and not exposed. You want all of those cells. And there's really no analytic technique that will work well if that data is along that diagonal from the top left to the bottom right. You can't and if that's the only data you have, you really can't separate out the impact of the exposure from the impact of the fact that the person is already likely to buy or not likely to buy based on other reasons. Okay? So with this, and coming back to that slide I showed before, well, yeah, okay, we fixed 80% of the problems quickly with my excellent team I had there at Nielsen. But there's still big ones where 200% errors exist on ROIs. We have this targeting thing. So what we did was we formed a digital media consortium, we called it. We already did, as soon as I got there to Nielsen when my company was acquired in 2011, I really, I wanted to work on digital media and make sure Nielsen was doing a really good job measuring digital media. So we had a digital media consortium 1 that was focused on store level data, market level data, account level data, national data, that kind of thing, all the kind of aggregate data, figured out how all that worked. And so we have a bunch of stuff about that, but it basically says granular data is good, kind of the summary of that. But there were some techniques. The store group model actually worked pretty well that we had developed at Marketing Analytics. But this one, Digital Media Consortium 2, is all about individual level data and versus store level data and which one is right. The various models apply to those two types of data. Under what conditions? Does it change under certain conditions when one is right in one circumstance but not in the other? Should they work together and how? And in the face of all these problems that I've alluded to here, the missing and inferred data, the targeting bias that I just talked about, and then short analysis windows. That is another thing that occurs. You might, since you're tracking an individual household, that person may be in a certain sample and out of it, and you just end up not having such a long analysis window that we have in Marketing Mix. So we got our partners and our great clients that we have at Nielsen to work with us together on doing some of these tests. We had all those people that I showed there, all those companies I showed there, Crux, NCS, Kellogg, Mondelez, P&G, Unilever, Nestle, ConAgra, Pepsi, Clorox, Anheuser-Busch, SCJ, Coca-Cola, Google, Yahoo, and Facebook all participated. I say Facebook's participation was a little less deeply involved than I had hoped. They really did participate a lot in the DMC1. They kind of didn't participate a ton in DMC2. I think at that point they were going through where they were having their walled garden or not having it, or letting us have certain data or not. They were going through a lot of changes. They weren't particularly helpful, but in any case, we did get some help from them. Everybody else really helped a lot, gave us all kinds of, and Facebook did give us some recommendations about which kind of analytics to use and so on. And what we did with those companies, by the way, is we got data from them. So every single of those companies I just listed gave us data, actual data for 2 different brands, and then both aggregate and disaggregate. We got additional disaggregate data from some of the other partners that we had, and we ran a bunch of tests of different types of models, as I suggested before. And then the way that we judge the models was the way that my team always judges all models. It's based on a bunch of different tests, and the reason why is because when you look at this table here of, okay, you can look at fit, you can look at standard diagnostics like t-values or t-values. We looked at coefficient reasonableness. Does this coefficient look about right? We did holdout samples, either like you save out the last bit of data at the last 10% at the end of the time series, or you can randomly pick observations in the middle of the data, which kind of helps if you have a bunch of marketing campaigns going on. If your model is by campaign, it's kind of hard to do holdouts. We don't have any data whatsoever for a campaign that's at the end of your series, so that's one reason why we use random holdouts. And then we use synthetic data. It's a really very important method for us. And we had another kind of holdout sample that I called policy-based holdouts. We don't do that too much. But I will say what the idea of that was, just so you know what I'm talking about, is that let's try and fit just a whole bunch of shallow discounts and try and predict deep discounts. It's kind of like it's exactly breaking the rule, or look at a whole bunch of very light advertising, television advertising, and then try and predict what's going to happen when you have very, very heavy advertising. It's exactly what they tell you not to do in statistics, and it's exactly what clients in business want to know because they've been doing a certain thing. They want to do something else different. What's going to happen with that? So that was the idea of policy-based holdouts. But in any case, as you see there, none of these are sufficient. Not one of these totally proves that you have a good model. So what we do is we run all of them, and I think we ran all but policy-based holdout in this case, and we did, and then tried to, from that, looked at which models perform best across all these different things. Okay, synthetic data is, let me explain that one, because we relied on that a lot, and so I should explain what that is. That is where what you do is you create data at a low level, like, say, for example, the household level. In DMC1, we did it with store level data. We started with that. We didn't need to, I think we actually did some things below that as well. But in this one, it's very, very important. We start at household level. We generate data that has known realistic lifts from running models that we feel we have some confidence in. You get like a 3% lift typically from this kind of thing, or a 10% lift from this kind of thing. And then we need realistic correlation structures. That's very, very important. You have to know if you tend to do a TV ad and it tends to be correlated with in-store merchandising, if that's the way these marketers tend to do things, then you need to have your data reflect that to get, to really pick up the kind of problems you're going to run into. So to do that, the best thing to do is use actual causal data, and we would do that every chance we could in DMC1 and DMC2. If not, then we have to use realistic correlation structures. So we'll measure how much is digital display correlated with search for these clients and so on based on the data that we got, and then we'll generate it with that kind of correlation. Then we aggregate the data up from the household level up to stores, and then up above that up to markets. And then we run a bunch of models at all those levels, at the household level, at the store level, at the market level, depending on what tests we're going to do. But you run models at various levels, and then you measure the fit and holdout and those kind of things. But you also measure, using synthetic data, the error and the coefficient. And that's the only way that you really can, the only way I know of, to truly measure an error and coefficient, because you never really know for sure what it is in all these any other tests. It's only when you create the data, you're playing God, and you make the lift be 4% for this, 4.38% for this particular event and for these particular audience, and then you go see if you can pick up that 4.38% correctly. And then the great thing about synthetic data, especially in these, one of the key questions we're trying to answer out of here is, okay, which works best, but under what conditions? Because conditions are changing. So it may be that, you found out, Ross, that marketing mix is beating some other method. Marketing mix is being a typical attribution model, the logit model, under the condition where you're missing 90% of the television data. But guess what? You're not going to be missing 90% of television data forever. So now we want to be able to say, well, what would happen if we got more television data? So we can easily vary correlations, data coverage, data errors, onboarding matching errors for attribution with the synthetic data. Okay, that's another great thing about it. Synthetic data should look like real data. Here's and it does for us. Below there is real data for one of the brands that was in our test. Actual data there. It's the base volume and the total volume, and then above it is synthetic data. It's all made up. Actually, by the way, somebody that's on the phone was on my team and helped create a lot of this stuff. But it looks very much like the other data. Not exactly, but it does look like it, and that's important that it does. Here's what we did with this in this digital media consortium and doing our tests and stuff. So we're trying to figure out what model's right and what's not. As I say, we used both simulated data and real data. And the way we kind of did it was we focused a lot on the synthetic or simulated data, and then found out, okay, in theory, because that is, you have to remember, synthetic data, you have to kind of start most of your conclusions with in theory, because it's based on assumptions about what the lifts are. Are they really 4.38% or whatever I said, or is it something else? And so you got to make sure that you're from this in theory. The way things should be actually correspond to real-world data. Here's a good example. This is kind of an eye chart. I'll just tell you what it is. That's on the left-hand side. That's promoted price elasticity in the top, and then regular price elasticity in the bottom. And we're looking at 6 different types of models: store level, store group, retailer, market multiplicative, market additive, and some sort of hybrid model, and seeing is the coefficient right? Because this is, again, synthetic data on the left here, so we know what the coefficient is. So green means, yeah, you got the coefficient pretty much exactly right. A yellow arrow up means it's a little too high. Red up means quite a bit too high. Double red arrows up means it's really, really too high. Your coefficient or your lift or your ROI is going to be really quite a bit too high. One thing we found from the synthetic data is that market additive model, this is a model that's been run by most marketing mix modeling companies for a number of years. Now, they don't usually, if they're being upfront with everybody, which they generally are, they will say, hey, our market level additive mix models, standard ones have been run for many years. They're good for media, but don't use them for price elasticities. Most vendors do say that. But this is why. So what we found out was, hey, yeah, with the synthetic data, that price elasticity, the promoter one should be quite a bit too high, and the regular one should be too high. Then we look over at that thing on the right. I guess it's kind of an abstract chart, but what it's showing is deviation from the model that we thought was the best, the store level model. What we found was that that particular model had the highest promoted price elasticity and the highest regular price elasticity. That is exactly what was predicted from the synthetic data. That's exactly what we saw in the real data. So notice if we only looked at the real data, we'd know it was higher than anything else, but we wouldn't know whether it's right or not. When we have something combined that says, A, theoretically, because of the way this model works and aggregation issues and so on, this one should be too high, and then it's higher than anything else, it's too high. We know it. That's how this kind of thing works. So here's some of the learnings that we got from DMC2. One thing is that tagging is a big issue. I'd alluded to that before. Tagging is where you have to actually put some kind of pixel or something on every single ad, so every digital display ad and any ad that you want to track, so that so when that ad comes up, the person sees it, it sends a signal to a server, and we know that that person with that cookie, which we will later try and tag that cookie to a person, but that particular cookie was exposed to an ad on this particular date and so on. That has a lot of errors in it. And one thing is that with third-party ad servers, where it's centralized in one company like DoubleClick, when they're doing, if for those kind of things that are done by a third-party server, that isn't too hard to tag correctly, although mistakes happen there. Some of these tagging is being done by young kids, kind of out of school that maybe haven't gotten the best training, and then sometimes they're not as diligent as they should be. But so that causes an error. But when it's not even a third-party ad server, but it's like a site, what they call a site-served ad, that's whereby the ad server is not doing it. It's like each individual website, hgtv.com or foodnetwork.com or something, there are all these different websites that you advertise on. Each individual one is serving up the ads. So if you want to tag that one, if this particular website does their ad site served instead of through or this particular campaign is site served and not through ad servers, you have to go tag it at each individual website. That adds all kinds of extra work, all kinds of opportunities for error. Besides that, there's some publishers and ad servers that have limits on the number of tags that they'll let you put in there, and so maybe your tag can't make it because a couple other tags are on it. Some publishers require tagging certification, or they just block ads. Facebook, Google Display Network. Google Display Network started blocking, not allowing tags on their ads right in the middle of our study here. So that was not exactly helpful. Log files can be an option. So you get a file that supposedly logs all the ads that person saw, but that has data loss due to if you wait a while and then you get the log file later, you may not be able to match to that person because of issues with cookie syncing. So log files don't work as well as tags. And then there's just a high turnover of the different turnover of the ad agencies and the ad operations. About a third of our advertisers in DMC2, they change agencies or ad servers during the 26-week measurement period we did. So I also want to point out all these issues on this page, these are not Nielsen issues, okay? These are industry issues, digital data industry issues. Nothing here is particular to Nielsen. So we, with those challenges, we have a new model. We actually didn't plan to test this one inside DMC2. We planned to test, marketing mix, a couple different versions of the store-level marketing mix, and some match panel analyses, and some logit models at the individual level. But in the middle of it, NCS came out with a new model they call Cognitive Advantage, and it's a two-part model that it's really focused on fixing this targeting bias issue. And so it's got one model that predicts exposures for all the different people, and one that predicts purchase influence, which media drives sales. And the two of them together attempt to correct for the targeting bias. So if you know that this particular ad that you're trying to measure the ROI on or lift of, if it is targeted almost entirely at people that are likely to buy, and you know that through your exposure model, then you're going to adjust the lift to some extent. So that's basically the idea of this NCF cognitive advantage model. Another aspect of that model is that it uses machine learning to figure out what are the best models. So basically it brings in all kinds of, it'll try a logit model, it'll try match panel analysis, it'll try different ones for each of these different models, the purchasing model and the exposure model, and then see which one works best in holdout samples, and then use that one. So it can change the algorithm that it uses from situation to situation and campaign to campaign. So as I had mentioned this before, we had one great thing about synthetic data is that you can have like a knob and you can turn it and see, because the key question was, under what circumstances is one method better than another? So in this case, you can take the data, like turn a knob all the way up to 11 and test under the various situations. So we start out in the perfect world. We got sales data for all the households, set-top box data for everybody, no tagging issues, no onboarding errors. Onboarding errors, by the way, are when you're bringing offline sales or traditional offline media into a data set that has pretty much digital media in it. You can an onboarding error means that you don't correctly figure out which households go together. Onboarding errors are a really, really, really big source of error. Nielsen did a test based on using the panel data that Nielsen has, and sent a bunch of cookies to two different onboarders. I won't say they are to protect the innocent here, or guilty, but for both of the different onboarders, these are the major onboarders that lots of us use, they sent us back to Nielsen, okay, here you go, these cookies go with these households. Because we knew exactly what the truth was for a truth set, which was maybe 20,000 households and 50,000 people, we figured out that about half of the time they were wrong. They would tell you, here you go, this cookie goes with this household. We go, no, it doesn't. Half the time it didn't go with that household. So onboarding errors are a big issue as well. But then we added in, so we start out with that perfect, beautiful data. We add in the fact that we're missing sales data for about 30% of households. We turn that crank up and down, but something like that was our base point. Then we added in that we're missing set-top box data for like 95% of the households, which is somewhere about right in 2016. Then we had 30% of the digital impressions are missing, and also some were onboarded to the wrong household. And then we had this targeting bias. That test was done kind of on its own. I think later maybe the team merged in with the other test, but they tested that as well. And then they said, well, what happens if we're like missing like really pretty much all the individual level data? Then almost all of it. Now it works best. And what we found here, again, those are all digital. Those are digital industry issues. They're not Nielsen issues. What we found was with perfect data, use a logit model at the household level. That works best. It's a parametric procedure. It's pretty much analogous to what we've been doing in marketing mix for decades, but it's at the individual level, and that works the best. Just like you kind of might think it would, it does. But you start adding in some sales data. You know what? We're missing 30% of the sales data. We're still okay. That model still actually performed pretty well. Then we added in some TV issues, and there's some non-trivial gaps in TV data. Then in that case, to measure TV, you kind of had to do better. Digital kind of would work okay with the TV gap with the logit model, but for TV, you can't use that logit model anymore. That parametric procedure, we had to go back to non-parametric procedures like a match exposed, unexposed, A/B test, match panel analysis for that kind of stuff. Then you had the digital data gaps. Now the digital has to start being done with a match panel analysis as well. Then you add in this targeting bias, and then it was kind of a close call between the match panel analysis and cognitive advantage, but it's one of those. You shouldn't be using, by the time we got all these problems, which, by the way, the real world is in those last two rows right now, and then the real world is moving toward the top rows, okay? But it's in the bottom two rows pretty much now. And then when we have like very little individual level data, you got to do a store level marketing mix model. It beat, not surprisingly, it beat models that they have nice data. You got 3 million households with all kinds of holes in it. A marketing mix model will beat that. So here is summing up the learnings from DMC2. I want to leave some room for questions here. We had a question, which is, it It's a new world. Things are changing. New types of data, new types of models. Which is right? When these things differ by 100%, 200%, 1,000%, which is right? The answer is it depends on the conditions. And what are those conditions? If you've got perfect data, use a household level Logit model. And that is probably where we're all headed slowly. With today's CPG data, by the way, I guess this is a good time to mention that we really did, all these companies you may know, these are CPG companies. We did not test with non-CPG data, and that data can be better. I think it is probably better in some circumstances and maybe not as good as others. But for today's CPG data, use a store-level marketing mix model for linear TV. It beats the attribution model that we did. But use one of these other new methods that I'm showing up and right, a household-level propensity-adjusted match panel analysis, something like that. And by the way, the one that we tested was my friend and colleague Brian Weichel. Dr. Brian Weichel is heading up Nielsen's analytics for Mix and MTA right now. He really liked a method by James Heckman. It's called a propensity-adjusted match panel. It was cousins and variance on that is a model that we found that predicted pretty well, along with the cognitive advantage method as well. So use one of those new methods. They really were very close. And to be honest, both teams told me that, Brian said, hey, listen, Russ, boy, I can fix it. Don't worry, I'm going to beat that cognitive advantage thing. Just give me a little time to refine this thing. And the cognitive advantage, the NCS people were saying the same thing about cognitive advantage. But the truth is that they're both quite competitive. But the main message is you got to adjust for targeting bias. I also should point out that at the beginning of DMC2, we asked all our different participants about what they advise us on different methods and something. It was unanimous between the analytics team at Yahoo, Google, Facebook, and also we talked with people at the University of Chicago too. They had some stuff of their own as well, and Stanford. All of them told us the most important, but probably the most important thing for you guys, Russ Boy and your team, you have to adjust for this targeting bias. And then should they work together? Yeah, what we, as it is now with today's data, CPG, we found that the best way to do this is run a household level model, one of these ones that adjusts for targeting bias. And then you run that on the household level data, get all the digital lists, and put those in as a Bayesian prior to a store level mix model. And that's what the thing is. That's what worked best as a combination method. So, summing up, this baby in the bathwater thing. There's some definitely new things in the marketing measurement world. There's most of the media is now targeted below the store level. That's new. There are non-trivial manual tagging problems. So your data, the clean data that we used to get from Nielsen on TV, and nobody's perfect, I'll say, but the relatively clean data, and better than any other kind of data for marketing and other kinds of industries that we get from Nielsen, it's not like that anymore at the individual level. It's being assigned. It's not being collected well. We got all kinds of just implementation, operational problems that Nielsen over decades worked out mostly. But now they're coming back even stronger, way stronger in digital. We have very incomplete and wrong data. This onboarding errors can be 50%. That's like a big deal. Very large targeting bias, and this data is much, much, much bigger. So those of us who grew up with SaaS and love SaaS, we can't use SaaS with this kind of data. We tried it. I tried it. I have a team of at Nielsen of a lot of people that were trained in SaaS, so I kind of wanted to stick with it, but we really can't for this data. So we're moving to Python and Spark and Scala and this kind of thing. Here's some things that are, it's old. This isn't new, but it's still true. You have to include a measure of base sales. You have to. That's a huge problem if you don't. You have to include ad stock. You need to include some sort of saturation or diminishing returns. And then you have to remember what we've known in statistics for a while. There's parametric and there's non-parametric procedures. Parametric procedures like Logit require relatively clean data. If your data starts getting all kinds of issues in it, you need to use some of these more robust non-parametric procedures like match panel analysis and so on. And the last one I didn't put on that last page is that selection bias, because that was when I did this deck, we were still kind of working the selection bias things into the rest of the research, but no selection bias, as everybody and their mother told us at the beginning of this, absolutely you need to adjust for selection bias. So those would be the 5 things, including selection bias, that I would suggest. So anyway, thanks very much for that. I do want to just say one more thing, is that I thanked a bunch of people at the beginning. I also need to thank my team that worked on this at Nielsen, Dr. Brian Weichel, Dr. Levin Carolin, Samir Saha and Dr. Yue Shah was on the phone. They did a great job and busted butt and worked really hard for over a year on this stuff. So thanks, everybody.
Thanks so much, Ross. That's really great. I think our online audience can get a flavor of the kind of excitement and energy that Ross brought to this presentation about this time last year at our Big Data Analytics and Media Conference at New York University, which is why this was voted one of the best presentations for 2016. We do have some questions, and we have a couple of minutes to address those. If we don't get to your questions, and if you have additional questions you'd like to ask Ross, you can reach him at Rosslink, ROSSLINK, at Outlook.com, and he will be happy, I'm sure, to reply at some point to your questions. And this archived version of the webinar will also be available to you. You'll receive an email shortly after we're done today, and you'll be able to click through, review the webinar, and pass that on to any colleagues that you'd like to share it with. So with that, let me just sort of work in reverse order of the questions as they came in. AJ had a question, Ross, that said, with such good synthetic data, as you say, you can play God, sort of invent your data and then test your assumptions against that. What is the value out of the actual data? Could you, in theory, build a sort of synthetic model and use that?
No, because the value of it is that you, as you're playing God, you don't really know, okay? We don't really know whether the lift is 4.38% or not. I mean, on average it is. On average it appears to be based on the, somewhat flawed models that we're running. So, no, synthetic data is extremely valuable, but always you should check your results against actual data and make sure that it's all aligned. And this is especially true when you're testing something where the assumptions matter a lot. Like if you're testing aggregation issues, that's one of the perfect things for synthetic data, because you know what you're doing. You're looking at data when it's not summed together, and then when it is summed together. That you kind of know how things work. So that's a pretty good one for synthetic data. But any kind of test you're doing where the actual truth and whether it's A or B matters a lot to how all the results are going to come out, you really need to check against the real data too.
Great, thanks, Ross. And sorry about might have been some feedback on my earlier question to you. We think we've resolved that now. There was also a question from Nick about how you might extend these remarks to the B2B world, the longer time cycles for making a purchase in the B2B world. Have you had experience with that, and any sort of advice about how to begin thinking about attribution and marketing mix modeling in the B2B world?
I would say no. The short answer is kind of no. No, we did a whole bunch of tests on CPG. Those are Nielsen's biggest clients. That's what we focused on. The data was best. We learned a lot from that, and I would suspect almost everything we found here probably applies to B2B and also non-CPG. But I'd say one thing that doesn't is that we found the same kind of thing that ComScore found in their Wither the Click paper, where we tried different metrics of digital exposure for predicting sales, and click-through was not a very good predictor of incremental sales. Impressions was a much better predictor. I think that finding is probably particular to CPG. So I don't know if I harped on, I don't know we talked about that much in this deck, but that was one, other than that one finding, which I do think very much will change, I think most of these findings probably apply to the other things. You just have to adjust for how good the data is in that other industry.
Well, and I think to your point, a couple of your key takeaways that I had from the original presentation are the issue of hyper-targeting and the failure to put in base sales. And I might turn that around and say that it's also an illustration of the long-term impact of brand equity on sales. A lot of sales is, repeat purchase, especially in CPG, but the brand equity, the reputation is bound to account for a lot of the B2B sales cycle. And unless you're sort of factoring that in, this is not simply a data science challenge of looking at short-term impact. You have to factor in the other things that can affect the model, as you pointed out. There was a more speculative question. I think this may have to be our last one. It'll be kind of a timely note to go out on, and that is you followed the controversy about the Cambridge Analytica's hyper-targeting that led to the success of the Trump campaign, some believe, and to the Brexit vote in Great Britain recently. Any comments about the use of the hyper-targeting or if that's what it was in that context. Anything you want to share?
That's a loaded one. Let's see. I don't know. Again, I want to stick to what I've actually tested and so on. I haven't tested political advertisements and targeting there. I will say I think we all know that as you target more and more, and as people select the information that they get and target for themselves the media they see, that is part of why we have so much division, because people only see ads that reinforce their pre-existing beliefs. So targeting is part of why we have division in the country. So there's a little good and bad there.
Yeah, good point, and interesting kind of philosophical note to end on. But I want to thank you very much, Ross. Again, great presentation, great energy, a lot of excitement. I'm sure you'll be getting other questions, and I want to thank our audience for being with us. Our next webinar will be held tomorrow, Wednesday, February 22nd at 1 p.m. Eastern, and will feature Peter Levin, Strategic Planner of the Data Center Group at Intel Corporation. And again, many thanks to the members of the MSI audience for participating in our member-to-member webinar series.